So hello everyone, this is lecture 36 for the electricity and magnetism. In the last lecture we were studying about the retarded potential and we have seen the formulation how to find the retarded potential, and we have also seen one example. So today we'll take the application of that and we will find the radiation from the moving charges. We will see that how the electromagnetic waves are produced due to a dipole and due to a magnetic dipole. Then we will see that how EM waves can produce from a moving charge, that is accelerating charge. So an accelerating charge and the changing current produce electromagnetic radiation. So static current or static charge don't produce EM waves because the accelerating or the changing electric or the magnetic field produce each other. So that's why only that can create the EM waves. So we'll study that thing only, the accelerating charge or the changing current. So now see, if you know anyhow the vector potential and the scalar potential due to these moving charges over the dipoles, then you can find E and B using the relation we already studied, that E was minus del V and minus del B by del T and del A by del T, and similarly we have find it for B, so that was del cross A. So if you know V and A, you can find E and B, and this potential will be retarded potential because here again we are using EM waves. And if you know these E and B, then you can find the Poynting vector that will show you that how energy is transmitting. And see, if you consider any source charge and that is changing current or anything it can be, so it is emitting radiation in a circular way. So we'll consider everywhere the spherical symmetry, so we'll use the spherical coordinate system. So that thing you must remember. And if you know this Poynting vector power radiated, that is nothing but power per unit area. So if you need to find the power particularly, you just need to integrate for the complete area for a sphere. So that will give you the power radiated. So it is just the S dot dA. So we know S is 1 upon mu naught E cross B dA. So this will give you power radiated. And now let's find the power radiated. If it is a static case, means charge is not moving, then we know how E is related, that is 1 upon R square relation we have, and for the B we have 1 upon R relation. Then EB will give you 1 upon R square 1 upon R, then multiply this dA will give you R square multiply, so that will give you 1 upon R relation. And if you are integrating for the complete space, means R tends to infinity, then this will give you 0, means power emission is 0 in the static case. But when it is moving, charge is moving, then the relation you will get, E relation will be of 1 upon R and B also with the relation of 1 upon R, and multiply R square will give you, R square will cancel out, so the resultant power will be independent of R term. So that's why it will give you a net power transmitted due to the electric charge. So that's how also we can define that how moving charges or accelerating charges can produce EM waves. So for time varying fields we will get power radiated because at that time it will be independent of R, the P. But in the static case it will be 1 upon R dependence, so R tends to infinity will give you power 0. So I hope it is clear to you. So let's see the first case, that is due to the dipoles. So we'll consider only the results, we don't need the derivation or the complete proof of that. So if you have a dipole, this is QT, means charge is changing with time, and this is minus QT changing with time, and this distance is D, and this distance is very small, less than means lambda, that is wavelength, and you need to find the EM waves or the power at this point transmitting due to this dipole. So this distance is very large. Now if charge equation is given in this way, means charge is changing with time, so we just assume Q naught cos omega t. So the dipole moment, oscillating electric dipole, will be given by charge multiplied distance, so QT multiplied D, and direction will be in the minus Q to Q direction, that will be Z cap. So QT is Q naught cos omega t multiplied D, so Q naught D can be written as P naught, so P naught is nothing but Q naught D Z cap. So you can write your dipole moment in this form. Now see, we don't need to see the proof. Due to these dipoles at this point, the V and A, we will write the direct expressions. So that will be this: V R theta t equal to minus P naught omega 4 pi epsilon naught C cos theta by R sin omega t minus R by C, and A will be depending on the R theta and t, that will be minus mu naught P naught omega 4 pi R sin omega t minus R by C Z cap. So this will be your scalar potential, this is your vector potential, and if you know your V and A, you can now find the E and B. You know the formulation. So due to this dipole, we need to find the electric and magnetic field at this point, only then we can define the EM wave. So if you know the potential V and A, so just E will be, this is your formula, minus gradient V minus del A by del T. So you know the V and A by and T, so you just substitute the value and find the gradient, and A del A by del T. So that will give you this minus mu naught P naught omega square by 4 pi sin theta by R cos omega t minus R by C theta cap. And again, as I told you, that you need to find these gradient or the derivation all in the terms of the spherical coordinates. So you will get E in the direction of theta cap, and if you find the del cross A again in the spherical coordinates, you will get this. So you just need to do the cross product of del and A. So A is here, that in z cap direction, and you just need to do the cross product, and you will get this in the direction of phi cap. So see, now to validate that if this is a EM wave or not, so we can say that, means we can see this, if E and B in the theta cap and the phi cap direction, so E cross B, that is theta cap multiplied by phi cap, will give you R cap. So that is the property of EM wave also, means it is these both are perpendicular to the R cap direction, means direction of propagation. So that's why we can say this is the EM wave, and the frequency will be omega, and this is monochromatic wave because this is depending on one frequency only. From here you can find the propagation vector, that is k also, that is omega t minus omega r by c. So omega by c will be your k. So speed will be nothing but omega by k. So in place of k we will write omega by c. So omega will cancel out, you will get c. So again the speed is c, and this theta cap multiplied by cross phi cap will give you r. So that is the property of EM wave. So that's how we verify that this is the EM wave due to a dipole. And again E naught by B naught, from here you will get C. And there is no phase delay, both are in the same phase. So these all are the properties of EM waves. So that's how we verified this is the EM wave. Now you have E and B for the means the field. So now we can find the intensity also and the energy also. That will be 1 upon mu naught E cross B. So that will be your power per unit area. So just multiply the E and B. From here cross product of E and B will give you this. Mu naught by C, P naught omega square 4 pi sin theta by R cos omega T minus R by C, and the complete square R cap. Now the power means we need to find the average value of this also. So average value will be cos square will give you 1 upon 2 term, and this is constant, this will remain same. So this will give you 1 upon 2, and just solving this you will get this. So this is your pointing vector in the direction of R cap, R cap. Now the transmitted power will be this multiply the area, complete area, and area you must take in the spherical coordinates. So that will be r square sin theta d theta d phi r cap. So again d theta is going from 0 to pi, and phi is going from 0 to 2 pi, and the sin theta, sin cube theta, and sin cube theta d theta will give you 4 upon 3. You can solve this, and this r square will cancel out, so you will get resultant expression in this way. And again this will reduce to this mu naught p naught square omega 4 by 12 pi c. This is your power transmitted inside a means due to a dipole, electric dipole, in the form of EM wave. So that this result you must remember, very important result. Now let's see due to the magnetic dipole. So again we will consider the same thing. There is a current loop, a small current loop, and this current is changing with time, I naught cos omega t. So due to this there will be a magnetic dipole moment that will be also changing with time, mt. And now due to this small magnetic dipole you need to find the electric and the magnetic field at this point, and you need to prove that that will be the EM wave. So again this B will be the radius of this circular loop. So B is very small than the wavelength, and lambda is very small than this R. This is a point dipole. So again mt is I multiply area. So area is pi b square and it. So it will give you m naught cos omega t, where m naught is I naught pi b square. So wire is electrically neutral. This wire is electrically neutral. So this scalar potential at this point will be 0. But the vector potential will be this. So you must remember this expression, minus mu naught m naught omega by 4 pi c sin theta by r sin omega t minus r by c phi cap. So again you have V and A, so you can find the E and B. So E is minus gradient V, so gradient V is 0 because this is 0. So only the expression is minus del A by del T. So just take the differentiation of this, it will give you E. So E will be in the phi cap direction, and B will be given by curl of A. So that will be minus mu naught m naught omega square 4 pi c square sin theta by r cos omega t minus r by c theta cap. So this is your E cross B will give you again, this is minus theta cap. So phi cap cross minus theta cap will give you r cap again. So it is again in the direction of perpendicular to both of these. So that is the property of again the EM waves, and you can just verify these things again taking the ratio, and again the k is again omega by c, so speed will be c. So this is again the EM wave. So that's how you can verify. Question can be asked from this, that verify if it is EM wave or not. So now let's find the power transmitted also. So power transmitted is 1 upon mu naught E cross B. So just take the cross product, it will give you this expression. This is mu naught by c m naught omega square 4 pi c sin theta by r cos omega t minus r by c, and this complete square and direction is r cap. So average of this will be cos square will give you 1 upon 2, so and everything will be remaining same. So this will be your average power transmitted per unit area. So total power transmitted will be, take the integration with the complete area. So again it is a spherical coordinate system, so again you will do the same, r square sin theta d phi r cap. So that will give you this expression, means sin cube theta 0 to pi d theta will give you 4 upon 3. So this is your power, and you can call this as power of magnetic dipole. And power of electric dipole, we just proved this. So question can be asked from the ratio of these two also. So that will be P electric divided by P magnetic is equal to P naught square C square by M naught square. From here you can see that electrical power is very much larger than the magnetic power, because it is this is coming here, so it will be c square depending on c square. That will be very large value. So P electric is very larger than P magnetic. You must remember this result. Now let's consider the last case, that is due to a arbitrary, means before that we just need to see a general formula for these two. Means here we consider that mt is means I is I naught cos omega t, but it can be any other variation of also this function. And here also we have considered the charge as q naught cos omega t. It can be another function also. So then how you solve if the function is different, and how you can find the power then? So it is a simple expression. So if pt is given in any form, then total power will be simply P equal to mu naught. So this P is the dipole moment. So capital P, power transmitted, will be mu naught, and the P double differentiation, and the average of that and square divided by 6 pi c. So this will be your formula for power transmitted. And for the magnetic dipole, so it will be mt, this is mu naught, and the m double dot is average square divided by 6 pi c cube. So let's consider P in this case. So we consider Pt was P naught cos omega t in the previous case. So P dot will be minus P naught omega sin omega t. P double dot will be minus P naught omega cos omega t. So average of this value and square will give you, means first take the square, that will give you cos square omega t. So that will give you 1 upon 2 average. So average of this will be P naught square omega 4 by 2. Now substitute this value here and you will get power as this. So this is the same expression as we get here. That was the P electric. So this was the same expression. So if you consider any function, if you know the PT, you can find the power transmitted. Similarly, you can see for the MT also, just consider the MT as we considered in the last case, you will get the same power. So if any other function PT, MT is given, you can find out directly the power. Now there is this last case, there is this charge which is accelerating and has the mass and the charge is Q and acceleration is A, and this is we are considering in the spherical coordinate system. So we need to find the EM wave or the electric and the magnetic field at this P point due to this accelerating charge. So you just need to remember these relations, because we need to see only those relations where the relation is 1 upon r, because only then the power will be given. Other terms will give you 0, because that r will be integrating from complete space in the infinity, so that will give you 0 other terms. So only 1 upon r, that will give 1 upon r square multiplied by r square. So only those terms will be considered where the relation is 1 upon r. So in this case the relation will be qa sin theta by r. You just need to remember this expression, that in this case accelerating charge, this is your relation. A is acceleration, q is charge, and r is the distance, and theta is this angle in the spherical coordinate system. And B is qa sin theta by r, and then S will be q square a square sin square theta by r square. So again the power transfer will be multiplied by r square, that will give you just multiply r square, that will be independent of r. So S will be this expression, you must remember, mu naught q square a square by 16 pi square c sin square theta by r square r cap. So total power will be, just integrate for the sphere or for the surface element, that is dA. So that will give you again r square sin theta d theta d phi r cap. So the power will be mu naught q square a square by 6 pi c. So this is the power transmitted due to a accelerating charge at the point P, which is at distance r, and acceleration is a. So again we need to see that what will be the direction of E at this point. So see, r in this direction, r cap in this direction, so E must be perpendicular to r. So it can be in this way also and this way also, that will both are perpendicular to this. So but there is one more condition, that A, R and E must lie in the one plane. So A in this direction and R in this direction, and E must be in that in this plane only. So this will be only this. So this is your direction of E, because R, A and E must lie in the same plane. Now let's consider one question based on this. An electron decelerates at a constant rate starting from an initial velocity u to u by 2, during which it travels a distance d. So an electron is decelerating and its speed is changing from u to u by 2, and in that time it traveled the distance d. So we need to find a total energy radiated in time t. So in this time where this speed is reduced, so how much energy is emitted or radiated? So we need to find the P. So P is nothing but energy per unit time. So energy multiplied time will give you the energy, means power multiplied time will give you energy emitted. So P is this for a charge, means the accelerating charge. So this will equal to P into T will give you mu naught E square a square T by 6 pi c. Now we'll just find how to find this value of time. So speed is changing from u to u by 2 and deceleration is a. So we'll use this equation v equal to u minus at, because it is decelerating. So v is final velocity u by 2, initial is u, from here t will be u by 2a. So we need to find this acceleration also, because we don't know this term. So s is nothing but, means second equation, s equal to ut minus half at square. So s distance is d and u is ut minus half a. In place of t we will write u by 2a, that will u square by 4 square. So this will be this. From here a will be 3u square by 8t. So now you have A in the known terms and T in place of A, just substitute this value. You will have time also in the terms of known terms U and D. So energy is this mu naught E square A square T by 6 pi C. So just substitute the value of T. In place of A, just substitute this, and in the last substitute T here. So you will get this value, and in place of A, again we can substitute this, so you will get your energy in terms of the known terms. Mu naught E square U cube by 32 pi C D. So this is the energy which is radiated when the electron is decelerated from U to U by 2. So this is the energy radiated at that time. Now second question is, what kind of kinetic energy lost due to radiation? So there initially the kinetic energy was half m U square, but its speed is changed to U by 2, and at that time energy emitted is this. So this energy and the proportion of this energy with the total kinetic energy will give you this second question, loss due to radiation. So that's what we need to find is, means radiated energy divided by the total initial energy. So it is E by half mu square. This will give you m square by 2, and E we already find it this expression. So either you can use this or directly this. So you will get the same expression in the last. That will be mu naught E square U by 16 pi mcd. So this question was asked in the previous papers. So you must remember how to find these things. So that's all for today. We'll meet you in the next lecture. Thank you everyone.